Hey POE folks, here's a thing on parallel circuits notes. Parallel is a little harder than series, but if you got what happened in series, you'll recognize a lot of things from parallel. So a parallel circuit is a closed circuit in which the current, so closed circuit in which the current is divided into two or more paths. And that's different than series, because series you had only one path for the electricity to flow. And then for electricity to flow. So parallel gives you choices, and series doesn't. But you're going to see, there's a lot of things that are similar. You're going to use Ohm's law still. It's just weird with the resistance. Okay, so a parallel circuit has two. We kind of just said this. Two or more paths for the current to flow through. The voltage is constant in a parallel circuit. And this is different because in a series circuit, the current was constant. So in a parallel circuit, the voltage is constant. And I remember this by saying PVC, like PVC pipe. So in parallel, voltage is constant. It'll help you out later on because it gets confusing on which one's which. So PVC pipe. So PVC when in parallel, voltage is constant. And then the sum of the current through each path is equal to the total current. So kind of like in series, you'd say the sum of the resistance equals your total resistance. Well, here the sum of the current is the total current. So it kind of flip-flops everything. There's total resistance is a little harder in this because normally in a series it's really easy, right? Well, in a parallel one, you're going to say that 1 over total resistance equals 1 over resistor 1 plus 1 over resistor 2. It basically creates an inverse relationship. The more resistors you have, the lower your resistance gets, which is how you can speed up things and run them in series and turn up the current really hot. Or another way to write this is if you want to solve for it all at once, you could just do 1 over all of those. And if you use parentheses or have a graphing calculator that allows you to do fractions and fractions, it makes it pretty easy to do that way. I usually do it this way, and then I just flip my answer with a 1 over button. I'll show you that later. All right. If one of the parallel paths is broken, the current will continue or stay on. And that's different than a series circuit. If a series circuit breaks anywhere, the circuit is broken. It turns off. If a parallel one, if you break one of the parallel paths, you can still keep your current on, which is kind of why a lot of things in your home are on parallel circuits, because you wouldn't want, like if you're, you wouldn't want if you turn the microwave off for your lights in your kitchen to go off. You want those to be, you can disconnect one of them and the other ones keep going. So, all right. So resistance is a little weird in parallel. It's not as easy as series, so we got to practice. So we're going to start with a really easy one. See how they have the same number? So if resistor 1 is 100 ohms and resistor 2 is 100 ohms, if these were in series, you would just add them up and say 100. But what you have going on here is some of the current gets to decide to go down this path, and some of the current gets to go down that path. So it actually lowers your total resistance. It's not like it's running through both the resistors. It's kind of choosing one or the other. And the way you figure it out is with that formula. 1 over total resistance equals 1 over resistor 1, which is 100 ohms, plus 1 over resistor 2. And if you do that in your calculator, you get 1 over 100 plus 1 over 100, which is 2 over 100, also known as 1 over 50 ohms. And then if you already have a fraction, you can flip it. If you want to learn how to do this on your calculator, I'll show you real quick. It's not hard. You got 1 over 100. I know I don't need to on this one, but when you get numbers that aren't as nice, you'll want to know this method. So 1 over 100 plus 1 over 100, hit equals, and then you use your inverse button, which is that to the negative 1 power right here. Boom, hit equals, and you get 50, which is the same answer I get here if I flipped both of these. So RT equals 50, which is weird, 50 ohms, which is weird for people to think. You're like, wait a second, didn't that say 100 and 100? How can it be less? And I told you, since you're giving paths for the electricity to flow, it actually doesn't hit the full brunt of the resistance. It's sharing the load of the resistance, so it's only 50 for 100 and 100. 40 and 80, same deal. We're going to do 1 over RT equals 1 over 40 ohms plus 1 over 80 ohms. Okay, now this one, you might not know what 1 over 40 plus 1 over 80. You could turn them into both 80s and get 3 over 80. But, we could also do it this way. Whoops. 1 over 40 plus 1 over 80 equals, I think that's 3 over 80. And then you inverse it and get your answer of 26.6 repeating. RT, 26.6 repeating ohms. Okay, which is weird. Look at that number. That's smaller than either of those. And by the way, that's a great way to check if you're doing it right. The total resistance should always be smaller than any one branch because it doesn't have to use up all this 40 resistance. Some of it will go this way and some of it will go this way. Now, here's a common sense check for you. Let's see if you know the answer to this. Will the same amount of electricity flow down both these paths? Or will one path get more attention, more current going down it? I'll pause, or you pause. The answer is this path will get more current flowing down it, because think about resistance like traffic. If these are roads and you have more traffic here and less traffic here, you're going to get more cars going down this way to avoid traffic, and you're going to get more current going through here, more cars passing by. This one, since it's a lot slower, you got think of this as like having construction. You're going to slow down the pace of this road, so you're going to have less going through. More electrons or cars going through here, less cars going through here. So the currents are going to be unequal. All right, this also works for 3. We just did a couple examples of 2. We noticed a couple things. It shares the load. It's always lower than even the smallest one you see. So if I see this one and I see 100 and 450, I know my answer is going to be smaller than 50. It's got to be. And I will tell you, the more branches you have, the more decisions the electricity has to flow, the lower your resistance gets. Because it's like, oh, I'm going to get slowed down here. I'm going to go a different route. And then once enough electrons go down this road, well, it's no longer beneficial for this electron to go down this road. So it's like, well, I'm going to go down this road. And then, so they're basically spreading out the traffic amongst many lanes. So I'm going to write this 1 over 100 plus 1 over 400 ohms plus 1 over 50 ohms. Okay, and I'm just going to do it all at once without that middle step. 1 over 100 plus 1 over 400 plus 1 over 50, and then inverse it. Boom. And you get 30.77 ohms. Now I kept all these answers because they're between 1 and 999. Sometimes you might have to move the decimal place over. All right, so whole new problem. This is how we solve a parallel circuit. Let me see. I'm going to stop this video since you have the notes down on how to do resistance and the front page, I'm going to stop this video and come back and just do a video with our 2 examples because I don't want to run out of time on here.